Let's take a look at the following question. What value of y is not in the range of the function y equals to 6x minus 5 all divided by 2x plus 3? First, let's look at how we can test a specific value for being in the range of this function. For example, let's consider y equals to 5, and let's think about how can we determine whether y equals to 5 is in the range of the function or not. Let's think about what would it mean to say that y equals to 5 is in the range of the function. By definition of the range, this would mean that we can find an x value such that when we plug it in into the equation for this function, the y value comes out to be equal to 5. In other words, y equals to 5 is in the range of this function precisely when the equation 5 equals to 6x minus 5 equals to, 5 equals 6x minus 5 divided by 2x plus 3 has a solution. We can now proceed to solve this equation and determine whether it has a solution or not. Multiply both sides by 2x plus 3. 5 times 2x plus 3 equals 6x minus 5. On the left-hand side, distribute 5. 10x plus 15 equals to 6x minus 5. Now combine the x terms on one side and the constants on the other. 10x minus 6x equals minus 15 minus 5. We obtain 4x equals to negative 20, and of course we can now solve for x. We do find a solution, x equals to negative 5, and that means that the value y equals to 5 is in the range of this function. Now if we had if we wanted to test a different value, we would proceed in a very similar way, except instead of 5 we would use that other value. So this is all very nice. However, you probably are thinking, well, we can test in this way a specific value for being in the range of this function, but how can we answer the question that the problem is asking, namely, what value y is not in the range of this function? So this is where we can now use algebra to test all values of y at the same time, rather than testing each specific value, testing one value at a time. We can use a letter in place of a specific value, which is essentially the main idea of algebra, that we can use letters instead of specific numbers to do, for example, calculations of this kind. And so we will now think about an arbitrary value of y, which we denote by letter b, and we will test that value y equals to b for being in the range of this function. Since we didn't specify what that b stands for, by going through this process, we will be testing all possible numbers for being in the range. And that will give us an opportunity at the end to see which values are in the range and which values are not. The process is identical. The process for determining whether y equals to b is in the range of this function or not is identical to the one that we just went through to test whether y equals to 5 is in the range. Namely, we first note that y equals to b is in the range of this function if and only if the equation b equals 6x minus 5 over 2x plus 3 has a solution for x. And I wrote these steps side by side so that you can compare them they are really exactly, the steps that we go through are exactly the same, except this time, everywhere we used 5 before, we now use b. Okay, so we get here, multiplying both sides by 2x plus 3, we get b times 2x plus 3 equals 6x minus 5. On the left-hand side, we distribute b. 2bx plus 3b equals 6x minus 5. We now need to combine the x terms on one side and the constants on the other. We have two x terms here, 2bx and 6x. We combine them on the left-hand side. So I move 6x from the right-hand side to the left, and the constant term 3b we move from the left-hand side to the right-hand side. We now get 2bx minus 6x equals negative 3b minus 5. On the left-hand side, we factor out x. 2b minus 6 in parentheses times x equals negative in parentheses 3b plus 5. And now we solve for x by dividing both sides by 2b minus 6. And we find x equals negative 3b plus 5 divided by 2b minus 6. We can factor out the denominator as 2 times b minus 3. Okay, so now let's think about what this tells us. Well, if we wanted to know whether y equals to b is in the range of this function, and what value of x is going to produce that y value equal to b, we only need to substitute that value of b into this formula. And we see here that if we are substituting a number that is not equal to 3 for b, then we get an x value, right? Because, we get a numerator, we get the denominator, and if b is not equal to 3, this denominator is not equal to 0, and we can divide to obtain an x value. So for all values of b except 3, we find an x value. And therefore, all values of b except 3 are in the range of this function. When b is equal to 3, we find that the equation has no solution because the formula that is going to give us an x value requires us to divide by 0. And if we go actually one line higher, if you substitute here b equals to 3 in this equation, then you will see that the left-hand side turns to 0, whereas the right-hand side is actually not equal to 0, regardless of what x is. And so you get an equation that looks like 0 equals negative 14. And of course, 0 is not equal to negative 14. Therefore, the equation in that case doesn't have a solution. Okay, and so our conclusion is that the range of this function consists of all numbers except 3.